All right, so for today's talk, I'm going to just recap several things. One is the Word Beyond batch, Streaming 101 and Streaming 102. If you are not familiar with those two blog posts, those are great. I strongly suggest to check those online on O'Reilly website. So those Taylor described really well, and we're going to recap some of the key points from these two blogs posts, and also talk about a little bit about Apache Beam and my understanding of how it works and some of the execution engines there and that we can leverage. And then going to just to focus on the Apache Beam Programming guide. This one is actually on the website that introduce how you actually use Apache Beam using that. And something that I do is instead of like using the word count examples, I create another producer, kind of like a stream that continues data to Apache Beam and kind of like play the data with that. And then we're going to do a little demo there and to show how that looks like. So going back to the streaming process, so why do we need streaming processing? So batch is great. A lot of times batch solve just the problem that we want, but sometimes some insight is more valuable and it's more valuable after it happens. So this can happen with, for example, like advertisement. If you want to do more like a real-time way and give more insight to the user, so that streaming and real-time that can place you in a better place to target your customer. And also sometimes like the sports, and you do analysis that in real time that give you a better way. So instead of like do that every hour or every 24 hours, streaming sometimes work really well to retrieve insight that give you more valuable result to you. And also a lot of times data just come into naturally as a stream of event. Think about the things that we have in the batch mode, for example, like the ETL jobs that we have, we run in usually every 24 hours, but that is like a human-defined window size on that. So in streaming, we also have a lot of different ways to define those window size. We're going to see that in a few slides. And I work at a meetup, so just to give you examples of how the data stream looks like. So you can see like this is the event happens in more real time, and you can see like data is actually streamed into the system. So it's very hard for us to stop this, pause the stream, and don't allow people to do RSVPs. But if we are able to use streaming processing and get more insight and to recommend like a different event to the target group in more real time, that can be very beneficial. And some of the use case I already talked, like patient care and monitoring your production lines, just the different use cases that you can work with streaming pipelines that it make more sense instead of like waiting for your job to finish for the batch mode. And there are several streaming analytic patterns before we jump into Apache Beam. I'll talk more about what we can do about those streaming analytic patterns. One is preprocessing. So think about one way that you can actually reformat or reshape your data somehow or do some filtering on the data set. And also, if there are some like a threshold that you can set, you can do alerting based on a system that you actually want to monitor. For example, like a CPU or memory usage that you can actually using streaming to trigger different event based on the threshold that you have. Another example is we can do some basic aggregations on top of the streaming. Aggregation is usually tied together with the window size. So think we really have a different window size that can help you to do, for example, like last hour on the data, you want to get more insight like a median or maximum values on top of those data set. So that kind of aggregations there. It's very hard to do across the entire streaming because streaming is like unbounded. So that's very hard to do. Usually we tie that back to the given window size. And also you can join different streams. For example, if you have some metadata, you want to do some lookups, and you can join different data and perform it that way. And another example is the machine learning model, and you can like send those data to the modeling and do a lot of different things across the board. And recap on the streaming one-on-one. So what streaming Taylor refers to is a type of a streaming processing engine that designs for the unbounded or infinite data set in mind. This includes like both true streaming, like data continuous running, or like a macro batches implementation, for example, like some Spark. In this blog post, he also mentioned like a Lambda architecture and also Kappa architecture. So there was the thing that he mentioned about the Lambda architecture is basically we're doing the compute difference, apply the same logic on both the batch layer and also the streaming processing layer twice. So there are different issues that can cause using that mode. So for example, like there are like a data integrity issues that if we did not apply that very carefully. And Kappa architecture is just we have one engines. Basically, it's more from like Kafka, Jacobs theory, and this is just we need to apply the same logic on one system, and that system is able to handle different things like streaming, and also you can apply batch on top of streaming. And another interesting thing that in the blog post, this is actually very early. If you read Google's blog post, like from the like Millwell and the Dataframe Flow, it's actually introduced like the event time and the processing time. So basically, the idea is when the event time is when actually things actually happens, and processing time is that record actually being observed in the system. So the difference is, as you can see, that event time is kind of like more the time when the event actually happens. There could be some latency between the actual record has been absorbed in the system. So you get this the difference is called the data scale. So the pink line refers to more of the reality, and it's very hard to get the ideal case. So in this way, we really like use some mechanism like a watermark to handle like if the data is kind of delay. And also in 1.1 there was a different window in function that has been talked. One is the fixed window. It's similar like we usually do the ETL jobs that we apply a fixed window size, for example, like an hour or like 24 hours. And sliding window, you can get a window that kind of like you move the window size a little bit toward to another defined window size. And session window, usually we have that, for example, like user behavior, and when the user actually click on some applications and they want to keep track of their sessions. So there are different windowing functions there available, and also in the Beam there are different implementations. So basically, this help you to do some data aggregations and to get more insight from your data set. And just to recap from streaming 102, so basically the idea is what result we are going to calculate is basically from different transformations that we have, especially in the Apache Beam, that there are like different things that we can do on that, and where the event are actually calculated. Those, like I mentioned, those will be on the window, and when the processing time become materialized, which means like the event when that actual result has been emitted to the downstream, that really it's using the watermark plus the triggers. And how do we refine those result set? Those are like through the accumulations. So there are more details that you can refer to those two blog posts. I think it's really great material to just to recap at this time. So Apache Beam. I think probably people already know this. Apache Beam, you can process both batch data, and it got the first letters and also streaming in the same engines. So like I said, you can think streaming more. We can apply a subset of the fixed window. So kind of like on the streaming, we can use that window to apply like a batch thing. So it's the batch is more like a subset of the streaming. So a little bit about Apache Beam. It's a unified programming model. So currently it's support like Java, Scala, and Python. It's well supported, and also I think Go is experimental. So you can think if you're a user that want to submit different jobs using the streaming pipelines, you have a unified language, different language that you can choose, but you have the same kind of like a model that you can use for different languages. Also, you have like different engines there. So there are a lot of engines that you can use during this like Beam sessions. We've gone through a lot of the engines. There are several that are like a lot of people use. If you are on the Google Cloud, a lot of people I saw is using the Cloud Dataflow, and we can use like Spark and Flink. There are also like a different community are like trying to contribute to this one. But today we're not going to talk most of those. We're just going to use the direct runners. Just to simplify that. So just to give you an idea how that looks like, you have like those different languages, and you have all those different runners. So Beam is just the middle layer that accept the task or like the streaming jobs that you want to run, and send that to different underlying backend runners or like engines. So Beam actually do not like actually run anything. It just try to like submit those two different engines there. All right. So when I first start off the Apache Beam Programming guide, feel free to refer that. So basically, it's a page on the Apache Beam that shows like how Apache Beam works and different functionalities there. So what I found is not only just a Beam, but also the other like stream processing framework like Apache Flink. We would like to use the hello world example, like the word count example. So the word count examples is great that you can basically get an idea of what's the streaming engine is doing, but it's like very simple. And if you want to do something more, it's just that you need to have a different data set that you can play with. So basically, this kind of just a word count example. So you can see that I grabbed this page from the, I think, Flink side, and just to show you like the different streaming engines also have this similar concept. That basically it's like you split a string by like delimiters, and you map that to different counters, and you do the and you key that by different, so you can get like different distributions and do a little bit of window size and do the count. That's kind of like usually how we like do the word count examples. And there are several things going on there. So a lot of times, because we just use a single paragraph in the word count examples, so it's not like really streaming, or like it's not like getting the continuous data source there. And also the time attribute, you need to associate some time attribute to that. Usually that will be the processing time when the actual event has been observed in the system, but it does not have when the record actually happens. So like the event time is not there. And also if you want to process more complex like the streaming processing, like join the data, well, you can do that, but a lot of times it's just not make a lot of sense if you want to like do data joins on like hello world examples, and also it's not really fun. So that's like the thing that I want to like do a little bit differently. So there's several things that kind of like a blocker to me when I try to learn this one. So first is finding the streaming data source is kind of like a little hard because you have to a lot of streaming source you have to like either like a pay or like if you're like in company and they already have like some streaming sources send data into Kafka that is really good, and the company allows you to like play with different streaming sources. That is great. But if you kind of like starting and you don't have like a really reliable streaming sources and you don't want to pay that much to get those sources, that is very hard, and the cost is another thing. For example, if you wanted to use like a pub/sub services, I think you can do that in free, but at some threshold, when you reach to that threshold, it's still like you have to pay some money to be able to grab that data. And also there are some different dependency there, especially for Apache Beam. So you have to either like deploy that on different runners, for example, like Apache Spark or Apache Flink. So you have to have those systems running more like a production ready. But Apache Beam actually have like a Java direct runner, so you can actually run that on the single node or single machine, which is the way that we're going to try to use and clear those blockers. So what I did is I created a custom data source, which kind of like if we don't have all those dependencies, like we don't have access to Kafka, we don't have access to like a WebSocket or any like internet. One thing that we can use is the file system. We can just read data from the file system and continuously monitor that file system, get the new event, and just send that data to our stream processing and just play with that data. So that's basically the idea behind this data stream processor. And the runner, like I said, I'm going to use the direct runner in Java directly. So this is way that people really like to do some debugging there. And also we're going to enable some event time and just have some fun on the data source. So I created a way called Marvel Fight Stream Producer. So the idea behind it is when the Avenger 4 endgame launches, and I combine with some ideas of the Super Smash Bros. And so it's kind of like a fight game. So basically you have like two different teams or like two different players, and you can basically like use their power, and different players has different skill range, and basically you can try to like create some random like different skill set range, and create a different like files and send that to the stream producer, and you can process that way. So we're going to talk more on that. So I found that first I need to find the Marvel hero fighting rank. So it's just a random page that I found based on the hero ranking. So you can see like if we have the Captain Marvel, that has like power 25, and this just like a mappings of all the hero powers. So later on we can use this one to do some lookup and also look up their powers. So kind of like that. And we need to define the like fight schemas there. So basically there are several things that I set up. One is the UUID. Basically it tells like which is what is the match IDs there, and also like you have like different teams, and also different teams have different players. It range to 1 to 100, and also like the team 2 also have like range 1 to 100. And for now I only have 25 characters there, so it's just a range from 1 to 24. And also different player has their own different skill set, so it's range from 0 to 2. And also you have like a different event time. So this one is the one that I want to enable, so we can do later on do some like event time processing there. One thing is about all of those data set. If you have like a range there, it's just a random numbers that has been generated. And also for the event time to be able to work, because we want to deal with some of the late data that we for now is just discarded. We want to have like the current time minus some random numbers within 60 seconds there. And how we find the winner of the game, so it's quite simple. So the logic that I apply is different players' skill set multiplied by their characters' fight power. So it's kind of just random things there. But this is the way that you can find who wins the game, and then later on you can try to apply those after the data transformations. So to put this together, let's say if I have a player one that play team one, or like team one has like player one, and the team two has another player that they are in the game. So you have Spider-Man and Hulk just to try to fight playing, and you have like different skill set there. So for like the Spider-Man, if the player's skill set is 0.7 and their character power is 10, and player two skill set is 1.2, and their character power is 6. So basically like apply that and multiply by their skill set and fight power. So that Hulk actually win in this case. So that's kind of like the idea behind, and we're going to try to see once we have a stream data set and who is going to win, and we can try to apply that. And the way that I created is, like I said, is everything is just randomized there, and we're going to use a file system there, and you have like there are several things that we can specify, like how often the file will be generated in milliseconds, and how long the producer will run in milliseconds. So just to make sure that on my local machine it won't like running too long until it's like crashing my laptop, and also like the number of fights that per file that is generated. So to put that together, this is how the data actually one line looks like. So later on, we're going to consume all of those data from a single file. You can think one file contains maybe like 100 of those different records, and they're all like different random numbers. One thing to notice is this event time stamps. Later on, we're going to use this one as the event time for this record, and this one because we're applying the random numbers there, also 60 seconds late. So it could be like the record is actually the watermark already passed, so that this event could potentially be dropped. And how are we going to read that file? So this just in the next few like all the slides there, I'll show a lot of like code there. So just this is how it looks like in the Beam. So basically, you actually use a text IO there, and kind of like try to watch a folder that keep having all the data that it's kind of like every 5 seconds you're going to like continue watching that, and this give us a peak collection. So it's like the way that in the Beam actually defines the data structure, and it's unbounded data in this way. So because we're like continue watching the folders there. And let's do one examples real quick. So we're going to find the player who plays with all the IDs of player 2. So it's kind of like a very straightforward, but we need to first, because it's a JSON file, we need to parse that to a class, and then do some filter on the functions, and also then parse that file to the output. So we know that. So a couple of things that we can do. Part 2 is more like kind of, you can think this as a map, if you're familiar with like map reduce. So we're just going to apply different like part 2 functions there, and basically transfer the data the way that we want. And there is one filter odd ID functions here. So we're going to filter based on the odd or even numbers there. And you can also write this way. So it's just different ways that you can write, like you can chaining those functions. So the task is very simple. You basically have like two functions there, and you have like an input type and also output type. So when you define this function, and you need to have an annotation there to indicate which function that you actually call to make sure that it's process element. So basically, it's just a very straightforward. And the output, you can call out the output, and you output whatever data you want to output with. But with the odd number, it will just send that. But with the even number, it just kind of ignore that. So it's kind of doing the filter there. And then we're going to do things a little differently. We're going to use the code group by key. So basically, the idea is because we just have the ID there, and we need to perform some lookups of what characters those ID really refers to, just to go back to the original data looks like. So like we don't know what character ID 22 or 18 refers to, so we need to perform some lookups in that way. But one problem that we have is because those actually keys belongs to like different IDs, we need to find a way to actually send all the keys to one node or one processor, so they can be allocated all together. So we need to break this a little bit. You can also use like a do functions. One nice thing about do functions, it can output 0 or 1 or multiple, more than one output there. So basically, what I'm doing is trying to parse the lines and getting like two different characters there, and the key will be there, just the character IDs there. So later on, we can send all the characters with the same key and to one node, and we can do some lookup that way. And then we're going to call the code group by key. So this is basically like try to allocate all the data with the character tag there that we before we are actually reading from the character data set, and trying to send all the those two data set together on one process. And so you can see this is like you can actually do like code group, and it will generate a code group result for you to further process. And well, there probably just too much information there, but basically the idea is because we are using that same different like the same character ID there, so the character ID and also the event character ID is actually sit together, so we can actually perform some lookups in this way. So if they actually have, if this is just what players it belongs to. If the player 1, I set their name, and if player 2, I get another name there. And then we're going to try to merge the fight because we already split the data to two different fights, and we need to use the UID to kind of merge those together. It's kind of like a similar idea, but just bring those two together to one result set. So now you get the character name there after lookup. And you can also do some combine functions there. So this one, I think I apply some window functions. It's not showing up there, but you can think this, we have like every 5 seconds, we try to get the mean of the average skill set within that player. So this is kind of like how the result set looks like. For each fight game that we want to find out who is the winner, so you can also add that to the do function, and just to update the data set there very easily. So the end result looks like this. So basically you have which player actually wins and the winner name there. But there is one thing that can happen is no such element exceptions. This is when I try to apply that within one window, and after running this, after 5 seconds, it actually breaks. The problem is because in Apache Beam, the state is always scope 2 per window, so we need to have like a global window and handle the state. This is because I have the character lookup just persist in that window. If that window pass, I don't have the corresponding record there. So I need to have some thing that kind of like persist in the state. So what I'm using is just the character state. You can specify like a mapping there, and kind of like keep track of that the characters in the state. And I don't do like a and also one good thing is on timer, you can pass that in, and it will do some callback functions to if you have like a state that you need to clear, and it can do things like that. So like I said, it's just a global window trying to trigger, and this is just repeatedly trigger that and waiting for that after the processing time. And also one thing to note here is you can also add like allow lateness, so it will persist that state for a while. But for now, it's just I discard that record. And if you wanted to like add like the event time, before we are using like a processing time more, and now we want to use the more like event time, so you can add retrieve that event time from the record. And the way that you do is when you output the record, you do output with timestamp there from the Apache Beam, so it kind of like associate with event time with that record there. And you can change that time domain when you process that record. And now you can like do like event time processing more complexly. So you can do like after word mark, and if it's like data has arrived late and you wanted to wait for like after processing time, maybe like wait for additional 1 second, and then just to materialize that word mark, and so continue doing that. And then we can do some like rankings. Basically, this one is just the ones that data has been materialized, and you can like do some fixed windows and do some like group by functions and apply the statistics over there. And it will look like something like this. So I'm going to demo that next. So basically, so that's like the entire like the flow looks like. So I'm going to first start the streaming process there, Apache Beam, and just waiting for that. And I have the like the Marvel source already there. So if we just start this one and just to kind of like generating all those data, and kind of like in the file system, it's kind of like if you see here, it's just like giving all the data there. You can see that like generating all of those, and but like the processor takes some time to produce those record. So the record will look something like I showed before. It's like this. And if you look at the timestamp here, it's like we have like a 5 seconds window, so you can see like there's some 5 seconds windows there. It could be like a record has been like fired late, so you have to like panel 0 or panel 1 there. So yeah. So those are some of the reference that I used to create those. So feel free to check those out if you want to like play some of the record that using this way. But like I said, this is not like just some like production thing. This is just my thing that I created on my local and try to understand this framework better to get like more like a streaming data source there. So, but yeah, that's it.